Next, we will be talking about symmetry. Symmetry in graphs can appear in two different ways. The graph can be folded along a line symmetry, or it can be rotated 180 degrees with respect to a point and remain unchanged, point symmetry. The most common types of symmetry are x-axis symmetry, y-axis symmetry, and symmetry with respect to origin. X-axis symmetry occurs if every y is replaced with a negative y, and then an equivalent equation is produced. Y-axis symmetry occurs if every x is replaced with a negative x, and an equivalent equation is produced. Symmetry with respect to the origin occurs if every x is replaced with a negative x, and every y is replaced with a negative y, and an equivalent equation is produced. Graphs of rational functions can only have two types of symmetry: symmetry with respect to the origin, or y-axis symmetry. If the graph has x-axis symmetry, then the equation of the graph is not a function, because the graph does not pass the vertical line test. If a graph does not pass the vertical line test, it shows that the graph does not represent y as a function of x. Knowing the symmetry of a function can make it easier to graph the function. If you know the symmetry of the graph and a point on the graph, you automatically know another point. This way, you only need to find one point on one side of the graph to find a point reflected over the axis of symmetry. These graphs show y-axis symmetry and symmetry with respect to the origin, which show that these graphs represent a rational function. This graph shows symmetry, x-axis symmetry, which shows that the graph does not represent a function. Now we'll be talking about holes. Holes appear on a graph when the numerator and denominator of a rational function have common factors. The hole occurs at the value of which the factor is equal to 0. The function here has a hole. After factoring the numerator and denominator, you can see that both numerator and denominator have a common factor of x plus 1. After canceling x plus 1 from both the numerator and denominator, the equation left is x plus 2 times x plus 3, also known as x squared plus 5x plus 6. This function shows that there is a hole occurring at x equals -1 because that is a common factor between both the numerator and denominator. The graph of the function looks like this. The hole occurs at point x equals -1 on the graph, and the common factor for both the numerator and denominator in this rational function is x plus 1. When x plus 1 is set equal to 0, the x value is -1. At this point, a hole appears on the graph.